Good day, YouTubers, and welcome back. We're not going to do anything real different today in terms of what we're going to show you for a regular process. Introduction, telling you a bit about the build, showing you the prep parts, and then building the engine. For any viewers that are new to our channel, I guess you can sit back and see something that's kind of cool for the first time. And for those who are our subscribers, which we want to say thank you for, we're going to go through the typical process, and what I can tell you today is the difference with our normal builds, which are 95% turbo builds or 3-rotor turbo. We're going to do a custom 4-port full bridge aspirated build today, so that's kind of cool and different for us anyway. So this particular engine is for a customer who wants to build a rally car. It's a first generation RX-7. And we have decided to use a early 13B 4-port, which is very similar to 12A end housings. Then we are going to fit it with 9.7:1 lightweight rotors, which are the high compression rotors, and RX-8 rotating assembly shaft and counterweights, also to match the lightweight rotating assembly. We are going to show you guys the custom Bridgeport work that we do on the CNC machine. Now, some of you that have seen our Bridgeport work in the past on turbo engines, very similar. The main port is almost the same program with the exception of the bridge is a very long aspirated bridge, not a real short turbo bridge. And if you remember, or those of you who have seen our stuff before, remember the short turbo bridge requires the matching notch on the rotor housing. We are going to show you the much longer matching notch on the housing, which separates this build from any turbo build. And again, it is an aspirated setup, so we've got high compression rotors and all kinds of modifications done for lightness and high RPM rather than strength and high boost. Okay? So sit back, we're going to take you over to show you the parts, and then we'll walk you through the build. See you soon. Okay, so these are the rotors and shaft. We've got the apex seals laid out as well. These are actually just Mazda stock apex seals. These are a great seal to use for aspirated use and even high RPM. They seal very nicely, and they do not require a whole lot of premix. So the rotors are the high compression 9.7:1. Naturally, we would choose those when we're trying to do a aspirated engine with good torque and good power and lots of RPM. The rotors have been lightened and clearanced on the faces, race clearanced. We've got new late style bearings in these earlier rotors to match the RX-8 shaft, the late RX-8 shaft. We also went ahead and balanced this rotating assembly and polished this crankshaft. So matching the RX-8 crankshaft would be the multi-orifice RX-8 stationary gear, which we've drilled and chamfered. That's not real nice because you get oil feeding from all sides of the bearing. So again, for high RPM, high pressure regulator from the FD RX-7, RX-8 gears and bearings. These are the hardened gears in the manual transmission car with the multi-orifice bearing. The back gear is also the same as the front, drilled, chamfered, multi-orifice bearing, hardened gear. The only modification you have to make when you're using the RX-8 gears and anything RX-7 is they do not have an O-ring groove on the gear, so you have to use flange sealer on the back of the motor, which is why we've already installed this. We've already done that process. Now, when you're choosing the early irons for the reason of these irons for an aspirated motor are a great choice because they have a lot of material and we want these ports as big as possible. So we're very close to the edge of the water jacket, but as you can see, we've got a very, very large port here and a very long bridge port. But we've got nice sturdy support from these early irons, and we have a lot of room to make this modification here. These irons have also been lapped, and you'll notice on the primaries we can do exactly the same size intake ports. That's again the bonus of using these early irons. There's a lot of material, so we're going to get Bridgeports both sides, Bridgeport type flow on both sides, and then of course on the rotor housings we have the matching notch, not just only longer than the turbo notch, but again on both sides. So the exhaust ports have both been ported for our Bridgeport engine, and outside of that we're putting on a lightweight racing meat pulley when we're done to match this nice balanced light rotating assembly. So the next time you'll see us will be at the engine stand when we're ready to assemble the engine. Okay, so we're ready to assemble this engine. Perhaps now that we have more of a bird's eye view of the port, we can zoom in here a little bit and just see that the port again is very, very close to either sides of the water jacket as far as we can go. This has all been done on the CNC machine, and you'll see this very long Bridgeport that extends down about 75% of the length of this port, and that's plenty of early port opening, extra timing, lots of flow, and a beautiful bridge that the CNC does to allow that corner seal to ride on each rotation. I'll show you real quick here before we actually put the rotor in place. And again, maybe a little hard to see, but so if you can imagine this notch here is now mated with the port below and is a perfect match. And again, that will go both directions, primary and secondary. And again, just to remind you, one of the reasons why we chose to use early irons like this is we can make the ports the same size as the primary and the secondary. So it's the ideal engine for excellent flow for aspirated, and in his case, aspirated road racing for rally. So it's a beautiful setup, and it'll work very, very well. The rotors are as ideal as they can be because they're 9.7s, which are the highest compression RX-7 rotors ever made, and the lightened clearanced rotors, mainly the lightning, will give him the high RPM advantage, and of course so will the balancing. So the engine will be designed for, we don't exactly know where it's going to peak out for power and RPM, but I would imagine on an engine like this, I think the owner originally was going to do downdraft Weber and has decided to do independent throttle body fuel injection, which is really cool because that's going to be the ultimate setup. He can take the most control over the fuel injection system and control the timing better than using a distributor, and will have excellent flow and probably peak out at around 9750. And here I'm going to put this assembly lube on here so we can get these apex seals in easily. And yeah, this is going to be a brilliant design. Again, it's not real common to do an aspirated build, but we do have the program on the CNC machine. And so that is what is brilliant about this build, is everything is going to flow identically, one side to the next, and one front rotor to back rotor, and the flow is just going to be ideal. So we might be able to do a follow-up video to this build and show you the actual car it's installed in, and maybe even show you some of the dyno sheets, results, you know, and possibly we'll get some footage of the car out in the real world on the track. It'd be nice. So just another thing to remember is a lot of the videos that you guys have seen us do in the past are turbo builds where we have the additional strength modification, which is our studding modification. And that not only is a little more time consuming for the assembly, but of course the prep that goes into the block is a whole bunch of extra work. And then of course you have the extra cost of a stud kit. So a lot of people are used to seeing us assemble blocks that are studded. Well, you won't see that today, and it's real simple. Studs are for strength and to resist the damage that can happen from detonation or overboosting and causing the block to crack. Is highly unlikely that we will have, anyone will ever see any kind of cracking on an aspirated block. Even if the engine is completely out of tune, it would be really, really uncommon to see, there we go, to see the engine get damaged. So we have no needs to install studs in this engine. And again, on that note, this assembly process is going very fast. One of the other reasons why we decided to sort of do a start to finish video of this engine, even though again some of the viewers have seen this all before, is just to show you how well everything fits together, and also so the customer can enjoy watching his build go together live on camera. And he'll be able to see it real soon, because we're about 10 minutes away from closing this engine up. And again, we'll do our very best to try to do a follow-up video to show you some results. Not 100% sure when he's planning on getting this project finished, but we'll definitely keep you informed if we have some information on that. These GSLSE rotor housings that we are using are very a great piece to work with, because they have the coolant seal grooves, as you can see, in the aluminum, just like the RX-8s do. And that is completely, obviously, uncommon for RX-7, anything 86 and later, because that's not the way that they chose to do it. So they literally ditched the coolant seals in the aluminum and went into the irons in 86 and maintained the coolant seal grooves all the way through until they stopped making the RX-7 in Japan, which went till 2001. So you don't get to see this a whole lot. And in fact, these coolant seals are smaller in cross section. In other words, they're narrower, they sit down lower, the groove is shorter, and they actually have so height and width is actually a smaller version. And it's the same as the original early rotaries, all the way back to RX-2. Even R100 had the same size grooves in the 10A motors, but they had a slightly different type coolant seal. And back in those days, they used to be a multi-piece. You used to put in the rubber, and then you used to put in the protective strip, a little strip of metal that went only in this spark plug area where the combustion takes place, to prevent the flame from getting at the elastomer. And so again, the GSLSE is a very specific housing, but it's something that is nice to have for when you're doing early stuff, to take advantage of the housings for the reasons we just explained in the video. And they actually were chromed slightly differently than the 86 up housings. And what you'll notice with the early stuff, 12A and GSLSE, which is what these are, and again, just so people are clear, these are factory 13B housings that were only offered in 84 and 85 in the GSLSE model. We use them all the time for various different reasons. Those are the same housings that we actually use to build our own 12A housings. In some of our other videos, you'll actually see that we've got thin versions of this where we've milled these down. So very common for us to use, not real common overall in the rotary world, but an excellent choice. Now, one thing I will say beyond all that is if somebody wanted to use a 86 and later rotor housing using early irons, it actually is possible, especially through us, because our CNC machine offers the availability to put the coolant seal groove back into the aluminum, and vice versa. In a case like this, we would actually, if we had no coolant seal grooves in the irons because they're early, and we had no coolant seal grooves in the rotor housings because they were later, we could pick and choose. My first pick, in fact, would be to groove these irons and put the coolant seal grooves back in the irons. And in fact, that's exactly what we do. I've got an extra tension bolt here because normally you have 18 volts, but because this is early, it's 17. And that's exactly what we do, is we've done it, and we do it whenever we do the 12A custom engines. We groove the irons for the coolant seal grooves. And then what we can do as well, beyond to go the next level up from there, is we can do the 86 to 2001 O-rings and sort of do an upgrade to the large cross-section coolant seals. And that's the only program we use. I mean, in other words, why would you go back to the old stuff and the smaller, sort of less durable, less robust? The other thing is availability. One of these days, Mazda's going to probably squash these early O-rings because they only work in 12As and old RX2s, 3s, and 4s, and GS LSEs. But it's common, you know, for people to want to sort of mix and match things these days. So that's another service that we do offer. We've mentioned it in the videos. I don't think we have a specific video on it. But again, we cut those large coolant seal grooves all the way around the perimeter of either the iron or the rotor housing. Can do either. I prefer on the iron. Interesting that Mazda went back to in the aluminum in the RX-8. But I think one of the main reasons they did that too is when they redesigned the iron and they have the exhaust port in the iron and such, they probably kept the coolant seal in the aluminum because it was more straightforward and not so close to the exhaust port in the heat where the heat builds up in the iron. So yeah, as you can see, this was a fairly straightforward assembly. Wasn't real exciting, didn't mean to bore anybody, and mainly for the customer. But you can obviously reach out to us if any of these services that you either see in the video or that you heard me talk about interest you. And if the perfect line bore, something we always check, and we will be obviously bringing more videos your way soon. And we're going to go ahead and just run through the torque sequence on this engine as we always do, and call this a wrap. Hope you enjoyed it, and we'll see you guys real soon.